Hey students, so today I'm going to be talking about simplifying exponents, and I'll start off by talking about what an exponent is. So what we have is what we call the base value or number or variable as it's written right now, and then an exponent is this little number that is smaller and to the upper right of it. And this base number right here is the thing that we are going to be multiplying by itself. And the exponent tells us how many times we're going to do that. So for example, if I have something like 4 to the third power, this means I'm going to take the base number 4 and multiply it by itself 3 times specifically. And when I do that, this shouldn't be confused with 4 plus 4 plus 4 to make 12. This is 4 times 4 times 4. So 4 times 4 is 16, times 4 again is 64. So exponents really make numbers get a lot bigger than maybe what you might expect. When you see something in parentheses like this, that means you are going to take everything in the parentheses and multiply it by itself this many times. So this would be -2 times itself 4 times. And I'd like to take a minute to think about whether this is going to be a positive or a negative value to start. We have 2 negatives here, which is going to make a positive, and then we have another 2 negatives that are going to make a positive. So we essentially have 2 positive things that'll end up being positive overall. So we can kind of think of it as like 2 times 2 is 4, times 2 again is 8, times 2 again is 16. This is going to end up being positive 16. And one thing I want to point out that some people aren't aware of is if you write something like -2 to the 4th power in your calculator, unfortunately, it only thinks this 2 is the base. It doesn't think this negative is part of that base value. So your calculator will think this is what you're trying to calculate. -2, the negative just kind of sits in the front there, and then the 2 is the only thing multiplying by itself. And so this overall is actually going to end up being a -16. So just be kind of careful with that. So of course, when you have numbers involved, you usually can just use a calculator to solve them. But when you have variables involved, you can't plug those into a calculator. And so we're going to practice simplifying something like this by hand. And what I would suggest is that you take the base number and expand it out like how we were in the previous examples. So for example, a to the 5th power is a times itself 5 times. And then that is being multiplied by a to the 2nd power. I'll kind of make a bigger separation here, bigger multiplication symbol there. A to the 2nd power is a times a. But really, if we were to rewrite this so it's just one base value with one exponent, we could do that because there's 7 a values all being multiplied together, and so that would be a to the 7th power. And the rule with that is really that you're just, whenever you have 2 of the same base value, you're really just going to end up adding their exponents together. But if you have a hard time memorizing the rules, I would encourage you to just expand it out, like so. Let's look at the next example here. So we have m to the 2nd power, so that's going to be 2 m's. And then x to the 3rd. I'm not even writing the multiplication symbol anymore. M to the 4th power, and then x to the 5th. Okay, so you can multiply things in any order. For example, 2 times 3 is 6, 3 times 2 is 6. You can switch these around and multiply them in any order. So we can almost think of it as like sort of combining like bases together. So I can combine however many m's I have. There's 6 of those. That'd be m to the 6th power. And then we could then combine all of our x bases together. And that would be x to the 8th, I believe. And we still, if you look at the original exponents, we are still adding. We just have to make sure that we add the same bases together, the exponents of the same bases. So m to the 2nd times m to the fourth is going to be m to the sixth. And then we're adding x to the third and x to the fifth together to get x to the eighth. So let's take a look at this example here. We have 3xy to the fourth power. Everything in these parentheses needs to be multiplied by itself 4 times. We have 3xy. I'm going to write it expanded out. We're really multiplying 3 to the fourth power, x to the fourth, and y to the fourth. And you could probably see that if you're kind of comfortable with distributing. That's really what's going on here. That one you might not need to necessarily expand it out, but just be careful to not do 3 times 4. A lot of people might say that's 12, but this is going to be 3 to the fourth power, which is going to reduce. I would use a calculator for something like that. So we got 3. This is the desmos.com/scientific website. If you want to make an exponent, you can use this little caret button above the 6 on your keyboard. It's like an upward pointing arrow. So Shift 6 would do that. And then fourth power, we're getting 81. What I actually typed into my keyboard was 3, this up arrow, and then the value 4, and it makes it become an exponent like that. So to write this fully simplified, I would do 81 x to the fourth, y to the fourth. Let's try that with this one here. You can think of it as distributing again. We're really expanding this out. We are tripling the number of x to the second powers that I have. We're tripling that. And then I guess I'm going to write it expanded out. And then we're also tripling the number of y's too. And so if you really wanted to expand this out fully, you would have xxy times xxy times xxy. And that will end up being 6 x's, so x to the 6th power, and 3 y's, y to the 3rd power. I'll give you a second to try example 5 if you want to pause the video. But again, I'm going to go ahead and distribute this one. And some people get confused. They think that this c is attached to this 4 right here, but it's not. This c does not have an exponent. Well, it technically has the exponent 1, a little tiny 1 there that we don't usually write. But we are going to, distribute, if you will, this second power to each of those. So we're going to get 4 to the second, c to the second, and d to the 8th. And so that's going to simplify even more. 4 squared is 16. And this, is clear if you also write it out in an expanded form from there. And so sometimes you'll have examples like number 6, where if you choose to expand it out, it might, be a lot of extra work to write on your paper. So you might want to logically think, okay, well, I'm going to end up with 5 m's that need to be multiplied by 10 essentially. And then we're going to end up with 2 n's that also need to be multiplied by 10. All of that to the 10th power. So maybe we won't write this expanded out 10 times, but you'll know just using multiplication that you'll end up with 50 m's, because there's 5 here times 10. So m to the 50th power. And then these double n's are also going to be multiplied to have 10 more of them, and so that would be n to the 20th power. And that, might be easier to think about if you are distributing that 10 there. Let's take a look at this example here. We have m to the 12th over m to the 3rd. A lot of people look at this and they want to say, oh, it's m to the 4th. 12 divided by 3 is 4. Well, let me show you how it looks once we expand it out. Okay, so I have 12 m's on the top here that are all multiplied together, and then I have my 3 m's on the denominator of this fraction. Now, when you have something on the numerator that's the same as the denominator, you can cancel those two things out. when they're being multiplied together like this, because m divided by m is just the value 1, and we can simplify it in that way. That's supposed to be canceled out there. And then another m is going to cancel, and then a third m is going to cancel. And now we've canceled all the m's out of the denominator. What are we left with? We're left with 9 m's on the numerator. So that means if I rewrite this with an exponent, it's going to have base m to the 9th power. And so this rule a lot of people tend to trip up with, but when you are dividing things that have the same base, you actually are going to end up subtracting the exponents from each other. Let's try example 8 out to see how that's going to look. Let's expand it. First, I have 3 x's and then 10 y's multiplied together on the numerator, all over 2 y's on the denominator. So what's going to happen here? Well, I have 3 x's on the top, but there's nothing on the bottom that they can cancel with, but these 2 y's on the bottom can end up canceling. If I cancel 2 of those with 2 of the y's on top, I am going to end up with 3 x's, so x to the 3rd power, and 8 y's, y to the 8th power. So that is how that's going to simplify, and we don't have to write anything on the denominator. So that is it for expanding practice, and let me know in live sessions if you have any questions.